Another bracketing method that we will see for the optimization is the parabolic interpolation. And in this, we use a second order polynomial. And we say that this is actually provides a good approximation to the shape of fx near an optimum. So here you can see the actual function. The true maximum is here. And this is the blue one is the parabolic interpolation. Again, we will have 4 points, 1, 2, 3, 4, and we will just draw a parabolic curve in between them to get an estimation of the true maximum. So there is only one line connecting 2 points. There is only one parabola connecting 3 points. And thus, if we have 3 points that join the bracket and optimum, we can fit a parabola to the points. That's the basic idea. Then we can differentiate it, set the results equal to 0, and solve for an estimate of optimal x. So the result becomes this. So we will have actually 4 points, but 3 of them are known. You can see x1, x2, and x3 actually. And we can find x4 based on this formulation. So x1, x2, and x3 are initial guesses, these ones. From those using this formulation of this parabolic function, we will get x4, which is the maximum of this parabola, which is closer to the true maximum. That's the basic idea. In this slide, we will show an example for the parabolic interpolation to find the minimum of this function. And we will start with these values, 0, 1, and 4. Basically, we first need to calculate the function values. And if x1 is 0, then fx1, when we substitute this into the function, is 0. Again, for x2 equals 1, fx2 is minus 1.5829, and x3 is 4, then fx3 is equivalent to 3.1136. So with these, we will use the parabolic interpolation. x4 is equivalent to, basically, it will be a very long writing, but let me write it down. x2 minus 1.1 divided by 2. And this is a long ratio actually. x2 minus x1 square, fx2 minus fx3 bracket minus x2 minus x3 square bracket fx2 minus fx1 bracket divided by x2 minus x1, and in brackets again fx2 minus fx3 minus x2 minus x3, and in brackets fx2 minus fx1. So when we write all the values here, like 1, 0, here again 1, 0, here 4, 1, sorry, 1, 4, 1, 4, 1, 4, and the function values are fx1 is here 0, 0, fx2 is minus 1.5829, minus 1.5829, here again minus 1.5829, minus 1.5829, and fx3's are 3.1136, 3.1136, and x2 was 1. So eventually x4 becomes here 1.5055. So this is the function value we found, sorry, the value of x we found, and the function value for this, then fx4 equals 1.5055 is equivalent to, when we substitute it into this function again, we will have minus 1.7691 as the function value. And this function value, you can see among these is the smallest one. This is smaller than this, and this, and this. So for the next iteration, we will use a strategy similar to the golden section search to determine which point should be discarded. One of them will be eliminated, and because the function value for the new point is lower than for the intermediate point x2, so we will check actually let me write it down here. F x4 is smaller than f x2. We will check the intermediate point, like the golden section. You can think that this is intermediate, and make a comparison between them. And because f x4 is smaller, then the new x value is to the right of the intermediate point. You can see that this is on the right side of the intermediate point. Then the lower point will be discarded. So if we order these, it's basically x1, x2, x4, and x3. So this is to the right of x2. Then we will keep these and remove this one. This is the basic idea. Remove x1. Then I equals 2. This is I equals 1 maybe. And this is I equals 2. In that, x1 becomes x2, which is 1. x2 old, let's say. And x2 becomes x4, which is 1.5055. And x3 becomes the value of 4, which is the old x3. The same actually. 4. Then we will continue by using this. We will find the new x4. This is old one. By using this parabolic formula. And we will continue to the iterations by using this. And in the following slide, I will show all the iterations and the results. I will not calculate these here because it's very long, but in the next slide you can see the results. In this slide we have all the results for example 2 for the parabolic interpolation method. For this example, you can see that we started with x1, x2, and x3 and obtained this. Then we used this because it's on the right side, we used x2, x3, and x4 in the next iteration. And here then we calculated the values, and eventually when we do this, we will have, so x1 changed here, x1 stayed constant, and x4 changed, you can see. Actually x3 stayed constant here. So in each iteration some values are staying constant based on the iterations or the results, and eventually here we will have the smallest value as you see 1.7757. so that's actually the same as the true value. So this is reaching very quickly. You can see even in 5 iteration, maybe 4 iteration, we were able to get the true value. But if we compare this with the golden search algorithm, even after 8 iterations in the golden search, we were able to reach this with 5.5. So not exactly this one, but this one reaches much more quickly. So this is more efficient in terms of iterations, but the calculations in one iteration is much more because the formulation is a little bit more complex.